It usually happens on the first cold day of the year when you have more calls than you can handle. The phone rings. It's the classic no-heat emergency call, complete with an upset homeowner. How you approach this service challenge will not only restore the heat in a hurry, but will make the most of your time when you so desperately need it. Make sure you have the right instruments for the job. You'll want to have an electrical test meter that can measure volts, ohms, and amps, an ignition transformer tester, a combustion flue gas analyzer to measure oxygen or CO2, a smoke pump tester, a stack thermometer, instruments to measure draft and system efficiency, and a pressure vacuum gauge with a scale for 0 to 300 pounds per square inch and 0 to 30 inches mercury vacuum. But probably the most important instrument to begin with is this: your own ear. What did the homeowner tell you about the erratic operation of the appliance? Was there any unusual noise? Has this happened before? Was there any odor or smoke? And what about this primary control safety reset button? Did the homeowner push it in an attempt to restart the burner? Armed with any verbal input from the homeowner, start a systematic check of obvious causes for no heat. Is there oil in the supply tank? Are all the valves in the supply line open? Is the thermostat set to call for heat? After you've checked, look at the burner itself, starting with the combustion chamber. If the homeowner repeatedly pressed the safety reset button, there could be liquid fuel oil accumulated in the combustion chamber. After removing the oil, measure the line voltage at the primary control input connection, observing standard electrical safety procedures. The voltage should be 115 volts. A voltage lower than 105 volts may cause an operating problem. If there is no reading at all, check for open switches or circuit breakers in the supply line. If the line voltage is normal, remove the primary control cover. If the safety reset switch is in the up position, it is on safety and the line is locked out. This indicates an electrical problem or a problem with another system. If these checks of the fuel supply and electrical supply haven't detected the cause of the problem, it's time to look at the burner itself. Start by disconnecting the fuel supply. Reposition the line so it will deliver oil into a container instead of to the burner nozzle. Tighten the flare nut at the pump discharge fitting. You're ready to reset the primary control. But stop, because you're going to have to be alert to the following conditions which occur almost simultaneously. To make it easier for you, we're going to examine the 4 basic systems. First, the electrical control system. Does the primary control pull in quickly? Is there any chatter or erratic arcing? Second, the drive system motor. Does it pull up quickly and smoothly? Do you hear the RPM change and a click as the centrifugal switch disconnects the starting winding? Is the coupling turning and driving the pump shaft? Third, the ignition system. Do you hear the ignition arc buzzing? If not, tilt the transformer back and look for the arc as the springs disengage the electrode rods. Fourth, the oil supply system. Monitor it and see if the supply is immediate. Is it steady? Is there any froth indicating air in the supply system? No oil means a restriction or a severe air leak. After you've done an organized, brief scan of these 4 systems, you should have found the one to pursue in order to find and eliminate the cause of the no heat call. Now, instead of listening to me, listen to the burner for each of these conditions as we go back to the beginning and examine each of the 4 systems in more detail. If there were a problem, you might hear something like this. What if you heard nothing? What if the relay didn't pull in at all? If that were the case, start by measuring the electric input for 115 volts between the primary L1 hot and the L2 neutral leads. Jumper in the thermostat TT terminals to make sure power is reaching the primary control. Check the connections for looseness. What if the relay does pull in? Check to see if the CAD cell is seeing enough light. To do this, remove the CAD cell leads from the control FF terminals. Attach the ohm meter leads to the CAD cell leads. Start the burner. Jumper the FF terminals. Your ohm meter reading should be less than 1600 ohms. What if the relay pulls in, but the motor fails to start? Measure voltage between the neutral lead and the primary control lead for the motor. If there's a severe voltage drop, the relay switch contacts may be defective. What if the relay fails to pull in, or is erratic, or chatters? Check for secure wiring connections. If they're secure, the control is defective. Replace it. The second condition is a faulty motor. If there's no motor sound at all, check for adequate voltage, or see if the overload is tripped. Measure the voltage between the motor primary lead and the neutral connection, making sure power is reaching the motor. Your reading should be within 10% of the rating on the motor nameplate. If it isn't, check the electrical input to the primary control. If it is higher than the output to the motor, then the control relay contacts or wiring are suspect. But what happens if you hear this? If the motor hums, but the shaft doesn't turn, the start switch may be defective. Turn the power off, then rotate the blower wheel by hand. If it turns freely, replace the motor. But if the blower wheel does not turn freely, you may have a bound fuel unit, a jammed blower, dry bearings, or a gross misalignment of the shaft coupling. Check for these conditions and correct them. Other motor conditions that can cause burner shutdown include excessive amperage draw. Check for this by starting the motor, attaching the amp probe, and reading the current draw. If it's more than 10% of the rating on the nameplate, you have an overload condition, a defective start switch, or shorted windings. Generally, you may not be able to correct these conditions in the field. Therefore, replace the motor. Noisy motor operation. Check the shaft alignment with the coupling. Tighten or loosen the motor-to-burner housing bolts in an alternate manner. Check for a loose blower wheel. Check for excessive radial shaft play. Check for loose start switch parts. Bound pump shaft. Check the coupling for slippage due to stripped end caps. Also check to see the coupling has not sheared away from the end caps. The third condition is the failure of the ignition arc. Let's listen for it. If you can't easily hear the ignition arc buzz, raise the transformer slightly until you can see the arc between the electrodes and the transformer output. A flame mirror may be necessary to check for arcing at the electrode gap. If the homeowner mentioned the odor of fuel oil or fumes, the ignition may be delaying, producing puffbacks, which create fumes. If the spark is inadequate or fails to get established, the burner will lock out on safety. In the ignition system, you have two suspects, the transformer and the electrodes. Start with the transformer, making the following electrical checks. Measure voltage between the transformer primary lead and the neutral connection. It should read 115 volts on the primary input side. Measure for a total of 9,000 minimum volts between the secondary terminals using a transformer tester. If the transformer shows no problem, look at the electrodes. Start with the contact between the electrodes and the transformer springs. There should be no arcing here. Check the gap setting on the electrodes to be sure it's set to the manufacturer's specifications. A bad setting can cause loss of ignition, which in turn leads to safety lockout. Inspect the electrodes for cracks, carbon residue, moisture, and pinhole leaks. Any leaks can cause faulty ignition. Replace any electrodes with worn tips or that look questionable. Usually a complete electrode assembly is recommended. Oil quality is the fourth condition you should observe at startup. Is there no oil delivery? Find the restriction, checking back along the supply line at each fitting to the supply tank, which you already know has oil in it. And here's the problem, quickly solved by reflaring the supply tubing using the tools in the toolbox. In just minutes, the tubing carries a new flare, and the supply line is ready to be joined again, this time without the leak. Is the oil white or frothy? Bleed the pump. Only when the oil is clear and air-free can you consider the problem solved. Let's review the steps we've described so far. You've checked the fuel supply line, the power supply line, both at the thermostat and at the burner, the primary control relay, motor operation, oil delivery, and ignition arc. In most instances, these simplified steps will lead you to the source of the no-heat problem. However, if you still have not found the cause, you'll have to look deeper into the system. This calls for a careful check of the burner performance during the fire test. To check burner operation, reconnect the nozzle line fitting in preparation for a fire test. Reset the primary control if necessary. Fire the burner, paying close attention to the light-off characteristics. Is the ignition fast and smooth? Are there any delays or puffbacks? Use a flame mirror if possible to observe the flame. Is the flame base stable? Close to the combustion head? Centered? Uniform in shape? And relatively quiet? Are there carbon formations on either the head or the chamber? Is there any impingement inside the chamber? These conditions can be caused by a defective or partially plugged nozzle. If this is the case, replace the nozzle with a new one of the same specifications. After you've found the source of the problem and you've corrected it, run the proper combustion efficiency tests as described in Volume 5, making note of any problems or operating conditions that call for routine or unusual servicing. Then, after cleaning up the area to better-than-found condition, move on to your next call. We hope by using the information in this tape and the others in the training library, each of your calls becomes easier for you and more profitable too. This video training library is provided as a service to the oil heat industry, brought to you by R.W. Beckett Corporation.